Greetings everyone, time to get to Pearson text section 12-3, continuing on our work with circles and the lines that intersect them. Today we're going to be talking about inscribed angles, and a second part of it will be a quick easy theorem on the measure of an angle formed by a tangent and a chord, and it'll be quick and easy because it follows right along with what we're doing with inscribed angles of any kind, alright? So, big question, what are the properties of inscribed angles relative to their intercepted arcs? What is the measure of an angle formed by an intersection of a tangent and a chord? And our vocab, inscribed angles and intercepted arcs. And again, we'll get right to it. All right, so an angle whose vertex is on the circle. Good color here. An angle whose vertex is on the circle. There we go, angle C. And whose sides are chords of the circle, right? Chord, chord. Angle whose vertex is on the side of the circle and whose sides are chords of the circle is called an inscribed angle. So C is an inscribed angle. All right? An arc with endpoints on the sides of an inscribed angle, like arc AB here, all right, that's called an intercepted arc. So you can think about it, these two lines cut across and intercept arc AB. That makes sense? So for this diagram, angle C is the inscribed angle and it intercepts arc AB. All right, our key concept, Theorem 12-11, is fairly straightforward. The measure of an inscribed angle is equal to 1/2 of the measure of its intercepted arc. So let's put it nice and simply. If this arc is equal to, I don't know, 80 degrees, this angle must be 40. Sound good? Okay. Now, one of the hardest things is that people want to confuse this with central angles, which we did a couple units ago, right? All right, central angles are different. Remember, a central angle would be one that connects from the center of the circle. Now, this would be 80 degrees because the measure of a central angle is the same as the measure of the intercepted arc. Okay, so don't get those confused. Central angles measure the same as the intercepted arc, but inscribed angles measure 1/2 of the measure of the intercepted arc. So there's our important bit for today. Okay? Next, how this is going to work. It's just an example here. Find the measure, solve for x and y. So here's x, here's y, and we're going to use that little rule that we just talked about. Well, first thing I see is that angle S is the inscribed angle that intersects the arc that gives us the answer that they want for P, all right? So let's put that up here, or sorry, the answer that they want for X. So if angle S is 70, X must be twice as much, 140 degrees. Makes sense? The intercepted angle is 1/2 the measure of it, the inscribed angle is 1/2 the measure of its intercepted arc. X is 140. All right, so if X is 140, erase some of this. Okay, if X is 140, let's just clear it all off. X is 140. All right. I just doesn't want to write again today. X is 140 degrees. Then PQ is 20, which means arc TQ must measure 160, right? It's 160 degrees. Therefore, Y, which intercepts that 160 degree arc, must equal 80. All right, that's the way it's going to work. So again, that's 70, x must be 140. If this is 160, y must be half of that, or 80. All right, using our 80-degree arc here again, let me just show you what's x. Well, obviously x has got to be half of what it intercepts. Okay, so the blue lines, you see how clearly they intercept an 80-degree arc. Therefore, x must be 40. Check it out, though. The green lines also intercept an 80-degree arc. Y must also be 40. Same with the purple lines. Purple lines, inscribed angle, intercept an 80-degree arc. All three of those sets of lines, blue, green, and purple, intercept the 80-degree arc. All right, therefore they must all be 40 degrees, which leads us to a corollary to the theorem. Any two or more inscribed angles that intercept the same arc must be congruent. Okay, next important thing, solve for x and y, solve for y. Well, ST is our diagonal, right? Therefore, the intercepted arc has to be 180 degrees. Therefore, angle y must be half of that, or 90 degrees. So, corollary to corollary also to 1211, any angle inscribed in a semicircle must be a right angle, or, put otherwise, an angle that intercepts a diameter has to be a right angle. Look good? Okay, so if we got a diameter, that angle has to be 90 degrees. Intercepted arc, or inscribed angle intercepting a 180-degree arc. Next example. Okay, solve for w, x, y, and z. What do you notice about w plus y? And what about x plus z? Well, let's start right up here. 100-degree arc. 100-degree arc tells me that since it's intercepted by never mind, hold on a sec. Back me up here. 160-degree arc, right? Going on, let's start over here. 160-degree arc from here all the way down to here. That's what y intercepts. Therefore, y must be 80, correct? Okay, good enough. Let's look at the next one. Let's check out these two right here. 60 plus 90, that tells me it's 150. Intercepted, the inscribed angle that corresponds to it is x. Therefore, x must be half of 150, or 75. Okay, so by the same logic, let's just say this 110 plus the 90, that's 200. That's intercepted by w. W must be half of it. W must be 100. And z intercepts 100 plus 110 for a total of 210. Half of that is 105. Now, important question, what do you notice about the opposite angles in an inscribed quadrilateral? Okay, x and z, well, they add up to 180, which would make sense. They have to add up to half of the circle, right? W plus y also have to add up to the other half of the circle. So, therefore, we've got another corollary coming on here. Okay, opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, so those are our three corollaries that go with Theorem 1211. Okay, just to review really quick, right? We got 1211 telling us that an inscribed angle measures 1/2 of its intercepted arc. The corollaries that go with it is that any two or more angles that intercept the same arc must be congruent, that any inscribed angle that intercepts a diameter must be right, and opposite angles, if we got a quadrilateral inscribed in a circle, opposite angles in that quadrilateral have to be supplementary, have to add up to 180. Okay, new theorem for us, Theorem 1212, all right, the measure of an angle formed by a tangent and a chord is, again, 1/2 the measure of the intercepted arc. Okay, 1/2 the measure of the intercepted arc. Therefore, for this diagram, x would have to equal half of the measure of the major arc formed by A, B, and C, and y would have to be half of the measure of the minor arc from A to C. Okay, pretty much just the same thing, but now we are using a tangent line with a chord. Okay, pretty much the same formula though. All right, so the kinds of problems we're going to get, I just threw one with all kinds of different tools here just to give you an example of what might happen here. So find the value of each unknown variable. I see A, B, C, D, E, and F. Well, let's see, what do I know? Okay, let's go back to our central angle. Since they give us a central angle of 120 degrees, I know this arc must be the same 120 degrees. Again, I put that there again just to re-emphasize the difference between central angles, which equal the intercepted arc, and intercepted arc angles, which are half of that. So I see that B intercepts that 120 degree arc, right? Which means B must be half of it, or B must be 60. Look good? All right. I know, let's see, what else do I know? I see a diagonal right there. Let me erase this right there. I see a diagonal going right along this line right here, huh? Right along this line right here, right? Okay, there's a diagonal, which means the arc over here must be a total of 180 degrees, correct? Therefore, 120 of them up here, E has to be worth 60 degrees. If E is worth 60, I see that it intercepts inscribed angle A. Therefore, angle A must be 30 degrees. Which would make sense also. A plus B, 60 plus 30, have to add up to 90 because again, look at this inscribed angle and how it intercepts our diagonal as well. These two have to add up to 90 as well. So A plus B, I got 60 and 30, have to add up to 90. Okay, what else do I need to erase here now? Get rid of some of this. And we'll put a couple things back here. A was equal to 30. B was equal to 60. All right, so I've got A, I've got B, I've got E. D. D is going to be fairly straightforward. It's an inscribed angle that intercepts a 56 degree arc. Okay, therefore D must be half of that, or 28. Okay, A is 30, B is 60, D is 28, E is 60. Okay, F. What do I know about F? F, I know, has to be whatever makes up the total 360 in the circle. Well, minus this 120 and 60 over here, that's 180. Well, the other 180 is F plus 56. So if I take 180 minus 56, I know that F must be 124 because, again, F plus 56 plus 180 have to add up to 360 all the way around the circle. And using our last theorem, 12, the tangent formed by this line here and this line here means that angle C must be half of 24 or 62 degrees. So those are the kind of things we're going to be dealing with. I hope that all makes sense, and I hope you have fun with this. I kind of enjoy this kind of thing. So anyway, that's what I know. Have fun using it. I'll see you guys later.